Welcome everyone to the prplMesh demo. My name is Frederik Van Bogaert and I am a consultant from Mind. We are a consultancy that specializes in embedded software, such as software for wireless network devices, which is the subject of our demonstration here. During this demo, we aim to show the interoperability and compatibility of prplMesh. We will do so using the interface that you can see on the screen, as well as which will show the network topology as the demo progresses, and we will also show some of the data model updates on the console that you can see on the bottom left of the screen. During the demo, we will be onboarding a couple of different wireless devices that you can see here before me. For the controller, we are using this device, a Minim GLINet B1300 extender. Additionally, we will be showing the practice of client steering, so to force a device to connect to a different wireless extender / repeater. So first of all, I will power on an agent device. So okay. To start off with, we will show the onboarding process of one of our agents to the controller, specifically the second GLINet device here, which we will use as a wireless range extender. Easymesh onboarding is done using WPS, so there's no further setup needed. When a device is connected over Ethernet, even that step is not necessary. We just need to wait a few seconds for the device to power on and to finish booting up, and then I will press the WPS button on both the controller and the extender, and they will then onboard, and you should see it appear in the topology view when it happens. So I'm going to wait a few more seconds before we do that. In the meantime, I can point out the updates of the live updates of the data model that you see in the console on the screen. This is the data model based on the Wi-Fi Alliance's data elements standard. This is the main API that we are using for prplMesh. In order to do the WPS pairing, I press the WPS button on both controller and the device. On the controller, it is a short press of the WPS button. Yeah, and on the extender, it is a long press. Okay, I pushed the WPS buttons and the device should appear right now indeed. So as you can see, there is now a new node on the interface representing the GLINet agent device, which has successfully onboarded to the controller. We can now use this device as part of our Easymesh network to get the information from it and to perform operations like client steering, which we will show right now. So we have a client device, an Android tablet, which my assistant is going to fetch right now, and which we will use to steer, which we will use to demonstrate the client steering behavior. So client steering is the practice of steering stations like smartphones, tablets, laptops, and other client devices to different agents in the network, different wireless extenders and repeaters, depending on conditions such as which agent devices are most congested and which one has the better signal or the better bandwidth available, things like that. So normally this is done automatically, but for this demo we are forcing the steering. Alright, so as you can see, the client device is now connected to the network, and it is connected to the controller, to the extender. And we can now steer it to the controller. So we do this in the web interface by looking at which interface we want it to connect to and what the MAC address is of the client device, and then steering this using this web interface. Of course, this interface is just for the demo. In actual in actual user interfaces that will be used for the client, we will have a more client, a more user-friendly interface to demonstrate this with. Alright, so my assistant will now do the client steering through the web interface. So we can do both steer a client to a different access point, which we call client steering, or we can also steer the client device to a different radio on the same device, such as a 5 GHz radio rather than 2.4 GHz radio. This practice is called band steering. So we can do either of those with prplMesh. All right. And now it's time for me to power on a different device. So let me go ahead and do that. This device is the ARRIS/Commscope X502, X5042. It is another Easymesh extender with a different Easymesh tag, so it is not running prplMesh. This device was kindly donated to us by Commscope, who is also a Purple member. And we will onboard the device to our network in this demo to show the interoperability of prplMesh with other stacks. This is made possible by our strict adherence to the Easymesh standard. Standardization and standards compliance is a big focus of the Purple project and prplMesh as well. And where the standards are lacking, we will try to contribute suggestions or additions to the standard, whether they are Wi-Fi standards, data model standards, or Linux kernel interfaces, or any other sort of conventions or standards. So I'll just wait until our device here has completed its boot, and then I can try to pair it. So once again, I will pair by briefly clicking here, and then also pressing the pairing button here on the ARRIS device. So as you can see, it is now blinking in different ways to let us know that it is pairing, and it should show in the interface soon. So let's just wait a few more seconds. Okay, there it is. Very well. As you can see, the Commscope agent device is detected as an Easymesh agent, same as the Purple extender, and we can perform the same operations on it as if it were running prplMesh. This is all thanks to our adherence to the same standard. For instance, we can try to steer our Android tablet to this extender, which we will try to do now. And there we are. The device is now successfully connected to the new extender. So now we proceed to showing of a different device. This device here is the Turris Omnia. So it is a device that we use to test our port to RDK-B with. I will now power it on. Alright. And in this case we've connected it over Ethernet. So when it finishes powering on, it will automatically connect to the network and show up as well as one of the Easymesh agents. It is one of our reference devices which we use to test our support for RDK-B. prplMesh supports both operating systems, both prplOS and RDK-B, and is well integrated on both operating systems. And this shows the portability of the prplMesh stack. It is also portable to any other Linux-based system with not too much effort. And as you can see, it is now present in our interface as well. Finally, we can connect another external device. This one is contributed by Sagemcom. It is their F266 wireless extender, running a custom version of prplMesh that they made for their clients. Alright. So we know of several deployments of prplMesh in the field, assisted by valuable prpl members such as Sagemcom, MaxLinear, and others. And we work with them to make prplMesh as easy as possible to port and to deploy in the field. So while we wait for this to show up in the interface, I can point your attention again to the data model, which you can see appearing in the console window to the side. So prplMesh is an active contributor to the Broadband Forum's efforts to standardize data models, the TR-181 data models, and we use our experiences with prplMesh to inform them about what the data model should look like, what sort of information we can provide, and what sort of interface, what the data model should look like for properly controlling devices in the Easymesh network. And our contributions can already be seen in the latest TR-181 standard updates. So we're quite excited to be working with them in their OB map subgroup. Just waiting for the device to, there we are. So now you also see the Sagemcom device in the interface. Thank you very much for watching and listening. It has been my pleasure to host this demo for you, and I look forward to greeting you elsewhere in the prpl Summit and beyond.